Las Virgenes tests subsea desalination for water security. Las Virgenes Municipal Water District is assessing whether subsea desalination could support a more resilient water supply strategy, as drought risk, climate volatility, and imported water constraints continue to shape long-term planning for California utilities. The district currently imports all of its drinking water through the State Water Project. That means nearly every gallon delivered to customers travels more than 400 miles from the Sierra Nevada before reaching local taps. In dry years, when snowpack declines and state allocations are reduced, that dependence becomes a major operational and planning challenge. To explore alternatives, LVMWD has partnered with Oceanwell on a phased subsea desalination program. The work began in 2023 and is structured around 3 stages: a reservoir pilot, an open ocean demonstration, and, depending on results, a potential commercial supply project. The first test was carried out not offshore, but in the Las Virgenes reservoir. Oceanwell deployed one of its modular filtration pods in the reservoir for more than 3 months, exposing the system to algae blooms, changing temperatures, wind, rain, and other real-world operating conditions. The pilot produced more than 150,000 gallons of highly purified water and recorded 93% uptime during the trial. Project materials state that the filtered water generally measured below 50 parts per million of total dissolved solids, compared with the World Health Organization's 500 ppm guideline for drinking water. Those findings are a useful early signal for utilities watching the technology, but they do not amount to full validation. A reservoir environment is not the same as open ocean deployment, where marine conditions, permitting requirements, and long-term maintenance demands will be more complex. A measured approach to desalination innovation, conventional desalination remains a challenging proposition for many coastal regions. Energy demand, brine management, marine intake impacts, coastal infrastructure, and public acceptance can all slow or limit project development. Oceanwell's approach is designed to move much of the filtration process below the water surface. At depth, natural hydrostatic pressure can help move seawater through reverse osmosis membranes, potentially reducing the amount of purchased energy needed for treatment. During the reservoir pilot, the system operated in shallow conditions and achieved specific energy use of about 1 kilowatt-hour per cubic meter. Oceanwell projects that a deeper subsea system could use up to 40% less energy than conventional land-based desalination, based on modeling and pilot validation. Environmental performance is another central focus. The company's life-safe intake system is designed to draw water at low velocities, reducing the risk of impingement for fish and other aquatic life. Pilot observations showed fish moving around the equipment, while testing indicated that some microorganisms captured during filtration could survive the backwash process and return to the surrounding habitat. For LVMWD, the goal is not to replace conservation, recycled water, or imported supplies. The more realistic opportunity is diversification. The district has identified a possible future offshore water farm several miles off the Malibu coast with the potential to provide up to 15% of its drinking water supply. That would not remove the need for imported water, but it could provide a more predictable local source during periods of drought or reduced state allocation. For public agencies, this type of resilience is becoming a core investment priority rather than a future-facing ambition. The next stage will be as much regulatory as technical. LVMWD is working with California agencies on a permitting pathway for offshore desalination technologies. Any future project would still need detailed review, covering cost, environmental impact, engineering performance, and value for ratepayers. For other water utilities, the LVMWD and Oceanwell pilot offers a useful model. Test emerging infrastructure in stages, gather operating data early, and avoid committing to full-scale deployment before the technical and regulatory case is strong.